Welcome back to our next video here in database-tutorials.com. In our last video, we talked about characters and CIN, where we learned how to do CIN inputs, as well as doing new lines and tricking it doing end line, and a lot of cool little things that we did in our last video. We also learned order of operations. So if you didn't see our last video, I definitely recommend you go back and check it out. I have opted to turn off my face camera, as I did a few videos ago, if you guys noticed. And this is to create a little bit more space here on our desktop to look at, and to help you guys focus a little bit more on what's being taught and not how the teacher actually looks. So in this video, we're going to go over floating point types, and let's go ahead and let's just jump right into it. So floating point types. We've talked about the type integer and type character, both of which represent numbers as integers, that is, numbers without a fractional part. Now let's examine a different way of storing numbers, as floating point variables. Floating point variables represent numbers with a decimal place. They have both an integer part to the left of the decimal point and a fractional part to the right. Floating point variables represent what mathematicians call real numbers, which are used for measurable quantities such as distance, area, and temperature. They typically have a fractional part. There are three kinds of floating point numbers. I'm sorry, there are three kinds of floating point variables in C++ type. Float, type double, and type long double. So let's start with the smallest of these, type float. Type float stores numbers in the range of 3.4 times 10 to 38 power to 3.4 times 10 to 38 power with a precision of 7 digits. It occupies 4 digits, 32 bits in memory. And so now let's take a look at our example here. The following example program prompts the user to type in a floating point number representing the radius of a circle. It then calculates and displays the circle area. So let's clear out our main here. And this example is going to demonstrate floating point variables. Let's rename that here. And then the first thing we're going to do in here is initiate a variable called float, and then name it rad. And then we can put constant float pi equals 3.14159f. So we're turning our float pi variable here as a constant that's not going to change. And then we can see out, enter radius of circle, put a space in there, and then this is going to be our prompt, right? Just as this right here was our type constant float, and this was our variable of type float. And then we're going to request the user to enter the variable that we're going to store, and this is going to get our radius. And then we'll say float area. We'll create another variable called float area. We'll set it equal to pi times rad times rad. So what this is doing is this is finding the area. We're taking pi, which is 3.14159 Fahrenheit. We're multiplying it by rad, which the user is going to enter, and then we're going to times that by rad again to get the area. And then we're going to see out area is, put a space in there, pass in the area that gets stored here in our float variable, and then do an end line, and we'll finish off our main function with a return 0. Now, if we were to build and run this, you can see, and actually you can't see right now. Let me make sure you can see. Okay, now you should be able to see. So if we build and run this now, we see a program that says enter the radius of a circle. So if I were to enter in 0.5, and it just closed out on me. Very interesting. Let's see if there's any syntax errors we have in here, or maybe I didn't do this right. Let's step back to the front here. So in main, I create a float rad, constant float pi is here, and then we do a cout into the radius prompt, and then we ask for the radius, right? And then we take that and set that equal to pi times rad, and then we cout the area is area, and then we end line, and then we do a return 0. So it looks perfect. So this is the area in square feet of a 12-inch LP record, which has a radius of 0.5 feet. At one time, this was an important quantity for manufacturers of vinyl. So as you can see here, and we just got by demonstrating floating point variables, we just got the area of a radius of a circle. Type double and long double. The larger floating point types, double and long double, are similar to float, except that they require more memory space and provide a wider range of values and more precision. Type double requires 8 bytes of storage and handles numbers in the range from 1.7 times 10 to the 308 power to 1.7 times 10 to 308 power with a precision of 15 digits. Type long double is compiler dependent, but is often the same as double, as you can see here. Floating point constants. The number 3.14159 Fahrenheit in circle area is an example of a floating point constant. The decimal point signals that it is a floating point constant and not an integer. And the F specifies that it's type float rather than double or long. So you can see here, floating point pi here is a floating point constant by the word const here at the front here. And then 3.1419 indicates it to be a decimal, and then F here specifies it being what does it say here again? Specifies it being the type float. So F here is for float. So let's move on here. The constant qualifier. Besides demonstrating variables of type float, the circle area example also introduces the qualifier constant. It's used in the statement, as you can see here. Constant float pi 3.14159. Float, and this is the type constant float. The keyword constant for constant precedes the data type of a variable. So it specifies that the variable of a variable will not change throughout the program. Any attempt to alter the value of a variable defined with this qualifier will elicit an error message from the compiler. The qualifier constant ensures that your program does not inadvertently alter a variable that you intended to be a constant, such as the value of pi and circle area. It also reminds anyone reading the listing that the variable is not intended to change. The constant modifier can apply to other entities besides simple variables. And we'll learn more about this as we go further along. So the constant type here, this is specifying that the value of the variable will not change throughout the program. And if we were to remove constant, then deeper in the level of the program, we could probably take pi and we could set that equal to something else. But as long as constant remains, if we were to try to take float pi and set it equal to another value, constant, we wouldn't be able to due to it being a type constant. An expression must be a modifiable value, as you can see. So that's not going to work. Now the hashtag define directive, although the construction is not recommended in C++, constants can also be specified using the preprocessor directive hashtag define. This directive sets up an equivalent between an identifier and a text phrase. For example, the line define pi 3.14159 appearing at the beginning of your program specifies that the identifier pi will be replaced by the text 3.14159 4159 throughout the program. This construction has long been popular in C. However, you can't specify the data type of the constant using define, which can lead to program bugs. So even in C, define has been superseded by constant used with normal variables. However, you may encounter this construction in older programs. So you could come up here and you could do a define, and then you could say pi, and then you could put 3.14159, and that would be a constant, and that would never change. But this could lead to code bugs, so we're better off using constant float pi and then setting it equal to 3.14159 Fahrenheit. Type bool. For completeness, we should mention type boolean here, although it won't be important until we discuss relational operators in the next chapter. We've seen that variable of type int can have billions of possible values, and those of character can have 256. Variables of type bool can have only two possible values, true and false. In theory, a bool type requires only one int, not byte, of storage, but in practice, compilers often store them as bytes because a byte can be quickly accessed, while an individual byte must be extracted from a byte, which requires additional time. As we'll see, type bool is most commonly used to hold the results of comparisons. Is alpha less than beta? If so, a bool value is given the value true. If not, it's given the value false. Type bool gets its name from George Boole, a 19th century English mathematician who invented the concept of using logical operators with true or false values. Thus, such true or false values are often called Boolean values. The setW manipulator. We've mentioned that manipulators are operators used with the insertion operator, the modifier or manipulate. The way data is displayed, we've already seen the n-line manipulator. Now we'll look at another one, setW, which changes the field of an output. You could think of each value displayed by cout as copying a field in an imaginary box with a certain width. The default field is just wide enough to hold the value. That is, the integer 567 will copy a field 3 characters wide, and the string pajamas will occupy a field 7 characters wide. However, in certain situations, this may not lead to optimal results. Here's an example. The width one program prints the names of 3 cities in one column and their population in another. So let's take a look at the width one program here. So this is going to demonstrate the need for setW manipulator, and we're just gonna create a long here, long pop1. We're gonna set that equal to 24258785, and then pop2, which is also going to be an integer, we're going to set that equal to 47, and then pop3 is going to be equal to 9761. So we just created 3 long variables using one long statement by separating them by commas. And then we're just going to cout location, and then we're going to pass in pop. Actually, we're not passing in pop. I'm sorry, we're creating another string, pop, and then we're going to end line here, and then we'll say vorticity, and then we'll pass in pop1, then we'll end line, and then we'll say high town. We'll pass in pop2, end line, and then this will be Lowville. We'll pass in pop3, and then we'll end line, and then this will be a return 0. So if we were to build and run this, we got an error. So let's see what's the cause of our error here. And we've initiated our variables correctly, comma, pop1, pop2, and pop3. See out location is there. That's going to be pop. And then that's going to be an N-line, Porticity, N-line, Hightown, N-line, Louisville, pop 3, and we need this here. So if I build and run this, then you guys should see that it comes up. So here's the output of this program: location pop, Porticity. If we were to pop 2425785, as you can see, pop 1, and Hightown is 47, and Louisville is 9761, because we passed in 3 long variables here in a cout and printed it out on the screen. Now, unfortunately, this format makes it hard to compare the numbers. It would be better if they lined up to the right. Also, we had to insert spaces into the names of the cities to separate them from numbers, and this is an inconvenience, as you can see here in location, Porticity, and Hightown, and Louisville. So here's a variation of this program with 2 that uses the setW manipulator to eliminate these problems by specifying field width for the names and the numbers. So let's look at it from a different angle here now. So now we come in here and we create long pop 1. We set that equal to 2425785. Pop 2, we set that equal to 47. And pop 3 gets set equal to 9761. And then we do a cout, and then we say population. We don't put an extra space there. We just go straight to N line, and then we say set W8 Porticity, set W12 pop 1 N line, set 8 Hightown, set W12, pass in pop 2, go N line, set W8 Louisville, don't put a space, and then you do set W12 pop 3 N line, and now you see here, let's just make sure we have this set up right. This is supposed to be cout set W8 location set W12, and then this is supposed to be population. And then this should be W. So that should do that. Right? So if we build and run this, and it looks like we have an error. Let's see, what do we do wrong? This is supposed to be cout set W8 location set W12 population N line, and then set W8 all the way down. So we're supposed to do an include also. We can do an include IO manip. This is for set W, and then it should work. So now if I do a build and run, now our app application should come up. Now you see here now the spaces aren't needed anymore because we use setW. The setW manipulator causes the number or string that follows it in the stream to be printed within a field n characters wide, where n is the argument to setW n. The value is right, justified within the field. So if we can see here, the type long is used for the population figures, which prevents a potential overflow problem on systems that use 2-bit integer types, in which the largest integer value is 32,768. So as you see, the output of width 2, location, population, porticity 2425785, Hightown 47, in Louisville 9761 in our example here. As a setW, we have initiated the number of spaces for us. Now we're gonna go ahead and end video here. So thank you for watching. If you followed along with us, you just learned how to use the setW manipulator using the include IO manipulator. So thank you for watching. If you're interested in our next video, head on over to database-tutorials.com and check it out. Until next time, guys. See ya.